Hello everyone, welcome to my YouTube channel. Please subscribe my channel and press the notification button. Today we are going to discuss correlation. Correlation is the tool used to measure the degree to which one variable is linearly related to another variable. That means in correlation, two variables are given and we find the relationship between the two variable. So that means correlation is the relationship between first and second variable. Next is types of correlation. First is positive and negative correlation. If two variables change in the same direction, that means they have the same direction, that means they increase or decrease in the same way. For example, if x is 100, 200, 300, 400, 500, that means here x increase, similarly y also increase, so that means this is positive correlation. If we take it as in this way, x is 500, 400, 300, 200, 100 and y takes 425, 360, 210, 150, 70. So in this way both the variable decrease. So this is our negative correlation. Next is linear and non-linear correlation. If unit amount of a change in one variable tends to bear constant amount to change in the other variable, then correlation is said to be linear. That means if increment in x is same in all the variable, here the difference between every observation is 10 and difference between every observation in y is also 70. So this means this is our non-linear linear correlation. If difference between the observation x and y is not same, so in this way that correlation is non-linear correlation. Next is very important method, Karl Pearson correlation coefficient. Let x1 comma y1, x2 comma y2 up to so on xn comma yn are n pairs of observation. That means the observation of x and y is given. Then the Karl Pearson correlation between the variable x and y is denoted as small r xy is defined as rxy is covariance of x comma y upon standard deviation of x and standard deviation of y. Here the covariance is in between x and y is 1 by n summation x minus x mean y minus y mean. So first of all, for covariance we find mean of x and y, then we find difference, these two difference, then we find product, and finally we get the sum of these product value. Divide by n, we get our covariance, and this is our standard deviation of x and this is our standard deviation of y. So with the help of this formula we can find correlation. So we take two observations x, that is 9, 8, 7, 6, 5, 4, 3, 2, 1. This is our variable x. and we take variable y 15, 16, 14, 13, 11, 12, 10, 8, 9. So this is our variable y. First of all, we find mean of x, and we know that mean of x is summation x by n. So we find here sum of x, and this is 45. So mean is 45 upon n is total number of variable, that is 9. So mean of x is 5. Next we find mean of y, that is summation y by n, and summation of y is 108. So it becomes 108 by 9, it becomes 12. So in this way we find mean of x and mean of y. Then we find x minus x mean. So we here subtract the given variable x and the mean of x, that is 5. So 9 minus 5, that is 4. Next 8 minus 5, that is 3. Next value is 2, 1, 0, minus 1, minus 2, minus 3, and minus 4. Next we find y minus y mean. So that means we subtract variable y 15 minus y mean, that is 12. We get 3. Next value 4. Next is 2. Next is 1. Then minus 1. 0. Minus 2. Minus 4. Next is minus 3. Next we find product of these two values. So that means we product here these two values, we get 12, 12, 4, 1, 0, 0, 4, 12, 12. And sum of these value is 57. Next we find x minus x bar square. So we squaring values of these. For the square is 16, then is 9, then is 4, then is 1, 0, 1, 4, 9, 16, and sum of these value is 60. Then we find y minus y mean square. So we square these values. 3 is a square, 9, 16, 4, 1, 1, 0, 4, 16, 9. So it becomes 60. So now we apply the formula Rxy, that is equals to covariance. Covariance means summation of x minus x mean, y minus y mean divided by n. So it becomes 57 by 9 upon root 1 by 9 into 60, and it becomes 1 by 9 into 60. So it becomes 57 upon 60. So this value becomes 0.95. So this is our coefficient of correlation. If we find R lies between 0 and 1, So that is our correct coefficient of correlation. And in this way we can find, we also use this formula for coefficient of correlation, Karl Pearson. So thank you so much. Hope you all understand this topic. If you have any doubt, please write in comment section. Thank you so much.